Welcome to Tech Talk with Trevor Galbraith, a video podcast that features industry leaders and experts from the electronics manufacturing community. Recorded at major events around the world and from the studios of Global SMT TV. Now here is your host, Trevor Galbraith.
And welcome back. My next guest today is Josef Ernst, who's the Managing Director of the ASMPT SMT Solutions Division. So welcome, Josef. Nice to see you.
Welcome. Also good to see you.
Yeah. So I guess you've been thrown in at the deep end, but you've been with ASM for quite a while. So you, or ASMPT, should I say. So you're very familiar with the company and how it operates. Digitalization and automation and data are key drivers at the moment for future of manufacturing. Can you elaborate on how ASMPT's open automation philosophy is shaping intelligent electronics manufacturing facilities for the future?
Certainly, Trevor. So, open automation comes with us mainly also with open interfaces, with standard interfaces. Mm-hmm. Why? Because we strongly believe in that data, the collection of data, obviously from our machines, but not only from our machines, but also via the third party, and also even necessary obviously from our competitors, will make in the future the difference. You collect the data, and by collecting the data, you can compute the data. Mm-hmm. With the software, which we provide on line level, but also on factory level, so we can react on real time. So especially, for example, as an example, when you talk about with the process engine, where we combine the printer and the inspection machine, yep, we usually react in real time. Mm-hmm. But when you also collect the data over time, then really we talk about big data from the whole SMT line, but also from the factory. Mm-hmm. Then we can also compute the data, and out of this also drive further improvements, which we then offer the customer to be implemented. And that immediately then will have an impact to the productivity and quality at the same time.
Okay. So does the degree of digitization and transformation differ regionally or between larger manufacturers and, between tier 3s and tier 4s, for example? And what challenges and opportunities are associated with these differences?
I wouldn't say that it differs from region to region or from tier 4 to tier 3 to tier 4 customers. It also strongly depends also on the complexity the customer do have, and also a bit on the philosophies the customers have. So we see this over the different regions that customers obviously step into digitalization because they strongly believe in that they can, out of this one, also grasp further benefits for the customer, which is as defined in productivity and quality improvements. But it doesn't depend really on the region, rather depends on the complexity, maybe here and there on the size. But even this I wouldn't say so, because so especially also in Europe, in the Western world, when we talk about smaller customers, they're also really interested in digitalization because they see the benefit what they can derive out of digitalization. As I just mentioned also before, really continuously improving the productivity as well as the quality.
Well, my experience with the smaller companies has been that over here they're quite open to digitalization, as you say, because they essentially come from an engineering background here in Germany. I haven't found the same with the smaller companies in the United States. They tend to be a bit more resistant to change on the smaller. The big boys, of course, they've got a clear business case there for it.
Means if you go on statistics,
yeah,
I could say you are right, but I would really watch out because all the customers looking for productivity improvements. And for sure, maybe then, let me say, with engineering background, then if you have a CEO or COO or also a CTIO, let me say, really coming from the engineering side, from a production side, they step into maybe a bit earlier. Mm-hmm. But we see also in AMCAS a trend towards digitalization. And it strongly really depends then on the top management. This we have to be clear. If you talk about an installation of a manufacturing execution system to really collect the data through the whole factory, this needs obviously you have to convince also the engineering level, the management level, but it needs strong support also from the top management, so from the CEOs, the CTOs of the related companies.
Yeah, absolutely. So I noticed that you've coined a new term here, one I've not really seen before, which is intelligent manufacturing, or intelligent factory, should I say. So how does that differ from the smart factory?
So it differs to Or maybe first of all, with the smart factory, obviously the primary target was, and that's still our target, this will never change, or I'm also convinced about not for the next, 10, 20, 30 years. It's always, finally we talk about productivity improvement, quality improvement, and also assure really on-time deliveries with limited or with the lowest investment or materialization what they is required for. But the step from smart factory to intelligent factory, it really took place. And why? Because we talk about nowadays really collecting the data over the whole factory. So really it's a complete holistic approach. And then it comes with software products where we also apply new technologies. So with a virtual assist, artificial intelligence is a core, as well as the natural language programming. And these are new technologies which we provide to our customers to improve their productivity, or also in this case, for example, improve the productivity of the engineers or operator, because they just raise a question and get the proper answer. And the system itself is learning because the answers are rated. And that's a way from how we call it now, that's the move from smart factory to intelligent factory.
So it's an intelligence assist, basically, for the operator.
Correct. It's an intelligent assist.
Yeah.
And this is just one example. Obviously, in the manufacturing execution platform, we also apply then the new technologies. And that's really makes the change now from smart to intelligent.
Okay, thank you for that. So can you share some examples then of how ASMPT's solutions have been instrumental in enhancing productivity and efficiency for your customers through using data analysis and interpretation?
Certainly. So I would like to come up with two examples. One is when we talk about big data analysis. So we really collected data over days and weeks at the customer side. We analyzed the data. And out of the analysis, so we really could improve certain parameters or adjust certain parameters, let me be more specific, in the placement machines with an immediate impact to the first pass yield and to the productivity. So, and this is proven to the customer.
Okay.
And this is what we implemented. So first of all, data collection, big data analysis, and then improve the parameters. So really impact to quality as well as productivity. And I would say that's most of the biggest challenge I would say the customers do have is that the material is components which they have to place in the right quantity, right time, at the right place.
Right.
And this is also where we provide a solution where we first of all plan, that we have an optimal plan. But obviously, if you worked in a production environment already, it does not come without disturbances.
Yep.
So we continuously compare the plan with the actual data and therefore adjust the planning. And really with this closed loop approach and then really a real-time adjustment, that's the way how you can achieve further improvements, mainly then when we talk about material productivity improvements.
Yeah, you can maximize machine uptime and make sure the
Correct.
efficiency.
Which is, you know, if you talk about 70%, there's still room for improvement, and you have even customers at 50%. Or if you're maybe at 98%, it's a slightly different story, but we are not yet there.
I don't think there's anybody there yet, quite frankly. Anyway, ASMPT's virtual assistant incorporates AI and NLP to support knowledge management on the factory floor. Could you elaborate on how this technology adds in real time problem solving and study and knowledge sharing among users? Now, I know you touched on the virtual assist a moment ago, but maybe we could just dive a little bit deeper as to how that works.
Okay. Yeah, sure. So with the virtual assist, where we apply artificial intelligence as well as the natural language programming. So the base for it are all the data which we gathered whereas the development of the products, the hardware products as well as the software products. And if you provide this software tool to the operator, to the engineer, and by the way, we also use it internally, also for our service technicians, the operator or the engineer do have a question. They have a problem on a machine. Maybe 70-80% of the case, because of their experience, they know immediately what to do. The remaining 20-30%, they have to talk to somebody, or they have to look into documents with 100 pages or a couple of 100 pages long, which is obviously very time consuming. In this case, you ask the virtual assist, he immediately gives you 1, 2, 3 proposals how to address the topic. And by rating then the answer of the operator, the system is learning. Means if then the second time another operator engineer will ask a similar question, we immediately come with a perfect answer.
Okay.
And this really helps a lot. And and we also are applying this one because obviously for our service engineers, so the products which we are providing in combination with the software solutions increase the complexity quite significantly.
Right.
In the past, an engineer could take care of a replacement machine, but nowadays you talk about the printer, the placement machine, as well as with a couple of software products.
Yes.
So one person cannot anymore tackle all this, and being in depth, let me say,
can't
from knowledge
remember
point
also
of view, all the topics. And
Yeah.
you go for a training, but if you don't apply it in the next couple of weeks, it's again lost information.
Exactly. So it's a training assist program and using AI essentially, which is happening a lot across the industry. Now, sustainability is also a significant aspect of ASMPT's corporate mission. Could you provide insights into the specific sustainability goals and initiatives that ASMPT is actively pursuing at the moment to reduce environmental impact?
So if I got you right, so we focus a bit more on environmental, so at the moment not on social and governance, and for sure on the environmental side, we do have, for ourselves, first of all, we follow here then also so different scopes, which is an official on the climate conference also addressed, so with scope 1, 2 and 3. And we have a clear target for scope 1 and 2.
Yep.
So we clear target that in 2035, our scope 1 and 2 emission will be at zero. We implemented already measures, so since 2019, so we could reduce it by 30%, and we have a concrete plan on hand that we will be able until 2035 to achieve here the net zero value. This comes obviously with whatever. You talk about green current, you talk about photovoltaic, you talk about also that we invest into, for example, a new air compressor, which has significant lower energy consumption. So this is all, let me say, planned. And because you know where we are today, you also can forecast the energy consumption, and out of this one we derived a plan how to achieve in 2035 latest zero.
Right. Well, it's a very important area. It's important for the environment. It's also important for shareholders these days. So it's certainly got some significance. It's good to see you're working towards these goals. So, Josef, I want to thank you for coming in and sharing some time with us today and giving us an insight as to what's happening at ASMPT and the SMT division.
You're welcome, Trevor. It was a pleasure to meet you.
Okay, thank you. Okay, so that's coming up after the break. We will have our final guest for the Tech Talk today, and that's coming up soon.